Imagine that you are given some differential equation. So let's say dy dx equals 3x squared plus 4x minus 5. And you are given an initial condition. So y of 2 equals negative 1. And someone wanted to know, well, what's y of 3? What's the y value when x equals 3 for this function? Well, you already know how to do this problem. So we're going to do it the way that you knew how to do this from before, which was we're going to use separation of variables to solve this differential equation. We'll use our initial condition to solve for our constant of integration, that big plus c. And then at the very end, we'll evaluate our function when x equals 3, and that will give us the answer. And then what we're going to do is look at this a different way with a definite integral. So we'll start with the way we know. So I'm going to start separating the variables. So I have dy equals 3x squared plus 4x minus 5. It's a dx, and I'm going to integrate both sides. So I will have y equals, this is x cubed plus 2x squared minus 5x plus c. There's our constant of integration. So what I'm going to do now is actually take my initial condition and evaluate this to solve for my c. So y is negative 1 when x is 2. So that's 2 cubed plus 2 times 2 squared minus 5 times 2 plus c. So negative 1 equals 8 plus another 8 minus 10 plus c. So on the right hand side I have 16 minus 10 is 6, so I'll subtract 6, and I have c equals negative 7. So my function is y equals x cubed plus 2x squared minus 5x minus 7. And then to determine y of 3, I'm going to take my 3 and I'm going to evaluate this when x equals 3. So y will equal 3 cubed plus 2 times 3 squared minus 5 times 3 minus 7. So 27 plus 18 minus 15 minus 7. So this is equal to 18 minus 15 is 3 minus 7 is a negative 4. So 27 minus 4 is 23. So we have y of 3 equals 23. So that's one way to do it. So we're going to do this problem again, and we're going to look at it in a different way. So our dy dx was 3x squared plus 4x minus 5. Another way, and I'm just going to follow the notation, I'm going to say f prime of x so that you can see this with the first fundamental theorem. So f prime of x equals 3x squared plus 4x minus 5. And I'm going to keep the same initial condition. So I'm going to say that f of 2 equals negative 1, and I want to know what in the world is f of 3. So it's the same problem, just written with slightly different notation, which I didn't have to actually change this. I just thought it would match a little bit better. So I'm going to use the fundamental theorem of calculus, which is the integral from a to b of f prime of x dx equals f of b minus f of a. But what I'm really going to use is this form. I'm going to add the f of a to both sides. So f of a represents my start amount, or my starting y value, plus the integral from a to b of f prime of x dx. This is the net change. Will give me f of b, my final value, which is what I want. I want f of 3. So my starting amount, my starting y value is negative 1. That happened when x equaled 2, so I'm going to integrate from 2 up until the x value I want, 3. So I've got my starting y value of negative 1, and I'm looking at the net change from x equals 2 to 3, and that will give me the y value I want at the end. So my f prime of x is 3x squared plus 4x minus 5. That's what I'm going to integrate, and that should give me f of 3. Which hopefully gives me 23, which is the answer we got last time I did this problem in a different way. So to do this, I have a negative 1, and then I'm going to do the antiderivative, so x cubed plus 2x squared minus 5x No plus c this time because I'm doing the definite integral, but I'm evaluating it from 2 to 3. So this will equal -1 plus, and then I'm going to take my 3, evaluate it there, 3 cubed plus 2 times 3 squared minus 5 times 3. And I'm going to subtract what I get when I evaluated it 2. So 2 cubed plus 2 times 2 squared minus 5 times 2. And hopefully I get 23. So I have -1 plus 27 plus 18 minus 15. I'll distribute the negative and multiply as I go. So minus 8 minus another 8 plus 10. And as I go on this is 26. This is 3, so plus 3. This is minus 16, and then I have a plus 10. So I've got 29. And then over here, negative 16 plus 10 is a negative 6. 29 minus 6 is is a positive 23. So my f of 3 equals 23, which is the same exact answer when I did the problem the other way.